Usually when we're using integration by parts, we can figure out what to set u equal to by thinking about our LIATE list, LIATE. However, that's not always the case. And this integral, all the functions involved are algebraic, so the list doesn't really give us much guidance on what to set u equal to. What I'm going to do instead is try and think of a way of rewriting the integrand so that it has a piece that I know how to integrate, and the other piece is a function that if I take its derivative, it gets simpler. So specifically, I'm going to rewrite this x cubed as x squared times x. Obviously, that's the same thing, and it might not be apparent how that actually helps me yet, but it does help me because now I can identify that this part of the integral, x times the quantity 1 plus x squared to the 1/3 power, that is something that I'll actually be able to integrate by using the method of substitution later. And I'll be able to do that by letting my new variable be 1 plus x squared in my substitution. So basically, what I have highlighted in red is what I'll let dv equal. And since that's going to be dv, I want the other thing to be u. I'm going to set u equal to x squared in this problem. And then, like I said, dv has to be the rest of it. So dv will be this x times the quantity 1 plus x squared raised to the 1/3 power times dx. Now that I know, or I've chosen u and dv, I can find du and v. Here, du is just 2x times dx. Finding v is a little bit more challenging because we need to integrate this function. However, you can compute this integral by using the method of substitution. So to keep the video somewhat short, I'm not going to do the entire substitution process, but you'd let t, your new variable, equal 1 plus x squared, and proceed from there. You should check for yourself that you end up finding that this integral gives 3/8 times the quantity 1 plus x squared raised to the 4/3 power. So I've once again found all the pieces that I need to apply integration by parts. Now I can plug it in and see if I actually made progress in this problem. So u was x squared. These two copies of v are the result that we just found, 3/8 times the quantity 1 plus x squared to the 4/3 power. And du is 2x dx. After I plug everything in, I should look for ways of simplifying my expression. One thing that I can certainly do is multiply the 3/8 and the 2 together to get a 3/4. Also move this x out front and simplify this expression a bit by getting rid of some parentheses. So now I have a new integral. This integral is simpler than the one that I started with because instead of having x cubed, I now just have x. And importantly, I'll be able to evaluate this integral just using the method of substitution. I can see that because if I take the derivative of 1 plus x squared, it's 2x, and I have a factor of x right here. So I will evaluate this integral using the method of substitution. Again, I'll skip the details of that, but you'd let t equal 1 plus x squared. After you apply the integration, the method of substitution to integrate that, you end up finding that it's 3/14 times the quantity 1 plus x squared, and the power has increased by 1, so it increases to 7/3. Now we're pretty much done. We just want to simplify our expression. Main thing that I'm going to simplify is that I have two constants that are multiplying each other. might as well multiply them together to get a single constant. And that constant, 3 times 3 gives 9, 4 and 14 gives 56. So I'm going to leave that as my final expression. It is actually possible to algebraically simplify this a little bit more, but this answer is fine as well.